Hello friends, welcome back to my YouTube channel. This is Assistant Professor Ramdas Pandit Bharsat. In this video, we are going to study about the standard enthalpy of combustion. So, before going to study, we should know what is meant by combustion. Do you know about the combustion? The combustion process in which chemical substance burn with the oxygen. And in this term, we have to see under the some condition, that is 298.15 Kelvin temperature and 1 atmospheric pressure. Okay, if you will take 1 mole of substance and burn completely to form the products, so that time you will get some amount of heat evolve or absorb. So that will be the standard enthalpy of combustion, and it is denoted by delta small c h degree, delta h degree small c, or delta h degree. Now see in this reaction, for example, the methane combustion is given, okay, and production of carbon dioxide is there, okay, and one more water molecule is formed there, okay, and you will see that much amount of standard enthalpy formations. So the standard heat of combustion is minus 890.4 kilojoule per mole. Now next term we have to see, that is the heat or enthalpy of neutralization and neutralizations. And in this case, if you add same amount of acid or base, they will get neutralized, or you will see the change in heat in that. Do you know about the acid base reaction? So that concept is here, okay. You will see in this reaction base, okay, plus HCl is given. That means strong acid, strong base and strong acids, and you will see the formation of salt and water, and you can see here the formation of heat is there, okay. Delta H is equal to minus 57.1 kilojoule. And for these reactions, HNO3 H2SO4 also you can use as a strong acid, and KOH also used for the as a strong base. And in this reaction, how salt and water forming? So after dilution of strong acid, strong base and salt in the aqueous solution, or you can take water, so all they are getting in a ions. So the reaction between strong acid and strong base may be written as like this: Na plus plus OH minus plus H plus plus Cl minus, okay. From this you will get Na plus plus Cl minus or water molecules and minus 57.1 kilojoule enthalpy. And cancelling out common ions of both sides, you will get only that much. H plus in aqueous, OH minus in aqueous, it gives water molecules in a liquid forms, okay. Now next topic we have to see, that is heat of reactions. Heat of reaction divided into 5 types. In that, the first one is heat of solution, second is heat of hydration, third is heat of fusion, fourth one is heat of vaporization, and fifth is heat of sublimation. So all they are we have to study in detail now. In that, first of all we have to see the heat of solution. And in this case, if you will take 1 mole of substance and dissolve into the large volume of the solvents, so that times does not produce any more heat change in this. That means in this case you will get heat but less amount. Now heat of solution is divided into 2 types. In that, the first one is integral heat of solution, and next is differential heat of solution. First of all, we have to see about the integral heat of solution. Heat producing by when a specific quantity of solute is dissolved in a specified quantity of a specified solvent under condition of constant temperature and pressure. So if you are adding a specific quantity of solute and solvents under the given condition, that is temperature and pressure, so you will get small amount of heat. And in the differential heat of solution, the heat change observed per further mole of solute dissolved in such a large quantity of solution that no significant changes in concentration of that solution. Now next type, that is heat of hydration, and in this case 1 mole of anhydrous salts are converted into hydrated salts after the attachment of number of moles of water, and also you will get change in heat. That means any salt is come in contact with the water, they get hydrated salt. You will see in these reactions when copper sulfates come in contact with the water molecules, they get hydrated forms, and also formation of minus 78.2 kilojoules heat or enthalpy. Now next type heat of reaction, that is heat of fusion, and in this case you can see the heat change that takes place when 1 mole of solid substance changes into its liquid state at its melting point. Now you can see example is given, water in solid state. So you can consider it is a ice and it is converted into liquid state. But when if you will give heat to that solid, that means to the ice, it will absorb the heat and that then it will convert into the liquid state. It means in this reaction it will be required to the solid for melting process. Okay, and that's why you can see delta H is a plus sign. Okay, that is plus 6 kilojoule it is required to that process. Okay, that means it is absorbed by any solid substance when it is going to in a liquid state. Now next topic, that is the heat of vaporization. It is also like a heat of fusion that we have to see now. In this case you can see heat change that takes place when 1 mole of liquid changes into its gaseous state at its boiling points. We know all about the boiling points, melting points. Okay, so in this case you can see again one example, one reaction like a heat of fusion. Water is in a liquid state, it gives, you can say, water in a gas state. So it is in liquid state and it is in a gas state, or you can consider as a vapor state. And for this process again require here heat. You can see again it is in a plus sign. When you will see delta H is plus sign, that means that meaning of this delta H plus sign is the requirement of heat to that process. It is a absorption heat by this particular substance. Okay, and in this reaction if you give heat to the liquid water, it will, that liquid will convert into the gas or vapor states. Okay, that's why it's a boiling, and obviously heat will change takes place in this process. Now last type, that is the heat of sublimation. Do you know about the sublimation process? The process in which the solid substance is directly converted into gas state. Okay, now in this case you can see here the heat change that takes place when 1 mole of solid changes directly into vapor stage at a given temperature below its melting points. Again, in this case you can see example reaction, iodine in a solid state, it is directly converting into a gas state, and when it will give the heat to that solid iodine. That means you can see in these reactions again is heat absorption by the solid iodine when it is converted into a gas state, or you can say it is in a, it will be converted into the liquid state. But in this case it is directly converted into the gas state, that is sublimation process. Okay, that's why again the delta H having a plus sign.